Welcome to Chem Talk, Breaking Down the Basics series.
Hello, everybody. My name is Julian, and today we will be going over the gas laws. Now, these gas laws hold for what we call ideal gases or perfect gases. When these gases interact, they will be perfectly elastic and bounce off each other as these small little gas particles in this giant game of pool. However, real gases are not perfectly elastic because they do have some small amount of attractive force and will interact rather than perfectly bouncing off each other. But we can dream. So when we have this perfect scenario, Boyle's law tells us that pressure and volume are inversely proportional to each other. So for an example problem, let's say we had a situation where your gas is exerting 4.5 atmospheres of pressure on a container, and that volume is 1 liter. However, you then, holding the temperature and number of atoms of gas constant, were to increase the volume to 2 liters. What's going to happen to the pressure? Well, we can take advantage of this formula to say that X would be over here. This would be our V2, or sorry, this would be our P2. So all we have to do is just divide this side. So 4.5 times 1, which is just 4.5, divided by 2 gives us our new pressure. And so 4.5 divided by 2 is going to give us 2.25 atmospheres of pressure for P2. We do have to remember our sig figs. Since this was given as 1 sig fig, that means we need to round up to 2 atmospheres of pressure. That's our first law. Now we can use Charles's law, which says that volume and temperature are proportional, not inverse, but proportional. So holding all other things constant, if you had a volume of 1.0 liters at a temperature of, let's say, 50 Kelvin. Actually, that's pretty low. I'll say 350 Kelvin. And then if we, let's say, doubled that temperature to 700 Kelvin, incredibly hot, what would happen to the volume of the container? This would be V2. Well, this tells us right here, all we need to do, multiply both sides by 700. So you're left with 700 divided by 350 times 1 equals V2. 700 divided by 350 is simply 2. So 2.0 liters V2. And sig figs would tell us to use 2. Put a period there, period there. That's how we use Charles's law. And now we're going to use Avogadro's law, which says that pressure is proportional to the number of moles of gas. So let's say we know we have 2 moles of a gas, and they're held at a pressure of 1 atmosphere. But then we pump in more of the gas, so we end up with 4 moles of the gas. How much pressure would we have? And this is going to continue, so 4 times 1 over 2, which is simply 2. 2 atmospheres of pressure. Voila. Now this all comes together in what we call the ideal gas law, which is PV equals nRT. And so if you're given an equation where you're given the pressure, the volume, and the temperature, and you want to find number of moles, you can use this. We also call it PIV-NERT. This R is a constant value. This long one, 0.082. The units are here. Just remember to turn whatever units you're given into these units if you try to use this formula. Thank you very much, and thank you for watching.
That's a wrap for today's episode of Chem Talk, Breaking Down the Basics series. Thanks for watching. If you enjoyed this video, don't forget to hit that subscribe button. Until next time, keep learning, stay curious, and we'll see you in the next Chem Talk, Breaking Down the Basics episode.